Hello and welcome to another one of these ADD videos. Today we're going to be discussing the concept of inverses. What is the inverse? Well, we're basically switching the domain for the range. And what in essence that means, the domain is the x values and the range is the y values. So we switch the x and the y. And when you're solving it, that's actually what you're going to be doing. So here when we're dealing with these problems, in order for a function to have an inverse, it must be one-to-one. What that means is that it passes a horizontal line test. In other words, each y value must only have one corresponding x value. So here you can clearly see at this point right here, and at this point right here, that y value of 1 has two x values from -1 and 1. So therefore, it does not pass the horizontal line test and have an inverse. Let's look at this set here. We have a few points, a few ordered pairs, and if you look carefully, the y value of 2 has two y values, one that's a 2 and the other one that's a 1. So therefore, no inverse, not 1-to-1, therefore no inverse. Okay, so whether you're looking at a set or a graph, you should be able to determine that it passes a horizontal line test like this function does. No matter where I draw this horizontal line, I end up with only one x value that corresponds to the intersection point of the horizontal line and your function. So that passes the horizontal line test. Okay, and therefore, because we pass the horizontal line test, we know that it has an inverse because it's 1-to-1. Alright, if we're looking at a set here, notice that all of the y values are different, so therefore we know that it's going to be 1-to-1 and therefore have an inverse. In this case though, if you look carefully, the vertical line test fails, and those of you that are on point should know that that means what? That we don't, or we're not a function, right? Because one x value has two y values. Good. Now let's look at the actual steps. What do I need to do to find an inverse? It's actually pretty straightforward. You switch the x and the y, and then you solve for y. Algebraically, whatever you got to do, solving equations. You should be able to do that by now. All right. What do you do to prove if they're inverses? Well, you plug one function into the other function everywhere there's an x. That's basically what you're doing here in the composites, the Fogg and Goff method, f of g of x and g of f of x, where one function is the inverse and the other function is the original function. So it's either that way or vice versa. It doesn't matter, however you want to look at it. Just plug one function into the other everywhere you see an x. And the only thing after you simplify should be an x that's left over. All right? So again, must be 1-to-1 to have an inverse, pass the horizontal line test. Also, if you're looking at a set, just see if the y values are repeated. If they are repeated, then therefore it has no inverse because it's not 1-to-1. And this is an example of passing the horizontal line test. And here we have a passing of the sets that is a 1-to-1 set, in this case not a function. Steps again, plug in or switch x and y and then solve for y, and then to prove their inverses, plug one in to the other. Okay, make sure you check out the example videos. More importantly, practice, practice, practice. Thank you and have a nice day.